In this video, we are going to be covering how nuclear fusion works, its potential as a clean and renewable energy source, as well as the people and disciplines that would contribute to making it a success. Now I'm sure what you're thinking is, why should we care? Well, the most important thing is the renewability and the cleanliness of this energy. Fossil fuels are providing the energy we need now. However, there's only a finite amount of them, and we can eventually just run out. When two light elements nuclei fuse and stick together, energy is released. The amount of energy released is expressed by a famous formula from a very famous scientist. Einstein's E equals mc squared. The first of these collaborating disciplines is the mechanical engineers. The conditions which could allow the fusion reaction to take place are supercritical. A classic human-made fusion reaction requires the plasma to be heated to near 150 million degrees Celsius. Here comes the problem. How do we create such a condition? This is where mechanical engineers come into play. One of the most popular solutions, which mechanical engineers have come up with to increase the pressure in the reaction chamber, is to add pneumatic pistons. While the reaction is in process, the pistons would pump gas into the chamber in order to maintain the high pressure required. With the help of the strong magnetic field, the fusion reaction could happen. During a fusion reaction, there is a lot of energy produced, which must be managed efficiently and safely. This is where electrical engineers come in. The role of electrical engineers is less about the actual reaction itself and involves more of measurement and control of the reaction, as well as what is done with the energy generated. First of all, they are responsible for constructing and monitoring all of the complex measurement systems involved in the reaction. It is very important for the operators to have a clear and reliable source of information about things such as temperature and energy output in order to make sure that the operation can run efficiently and safely. The majority of the role, though, involves designing an effective way of converting the heat energy from the reaction into electricity and getting it out onto the grid. As with many scientific projects, funding is an ever-constant concern. Seeing as the construction of nuclear fusion technology can cost millions, even billions of dollars, funding becomes even more vital than ever. Government is usually one of the main contributors to funding fusion research-related projects. In fact, governments from multiple countries all over the world come to pool money together in order to fund the ambitious and extension fusion projects, creating an international partnership. In order for fusion-based energy to become a sustainable energy resource for future generations, engineers and scientists have to work diligently with government employees, lawyers, and even politicians to obtain the funding in order to do so. Overall, it requires a large group of individuals and disciplines to achieve fusion-based energy. For example, mechanical engineers must work with nuclear engineers on the reaction chamber, as well as with electrical engineers on generators. Additionally, engineers must work effectively with governments to find the funding necessary for their projects. In conclusion, I hope you can now see the variety of skills and collaboration that is necessary in making a project like this successful.